Okay, so welcome back, guys. This is lesson number 23, where we're talking about Taylor and Maclaurin's series. We're going to eventually get to 1 over 1 minus x eventually. We want to talk about now Taylor's series for sine and cosine. So in the previous two videos, you guys should be pretty good now of what a Maclaurin series for sine is, a Maclaurin series for cosine, and then how to manipulate sine and cosine to like sine of 3x, cosine of x over 5, etc., etc. So let's look at now a Taylor series, the Taylor series for sine and cosine. I have to stress right now that what we have done in the past two videos is completely different. We don't use the same numbers. The exponents are not going to go away, and you guys are going to see what's going to happen here. So again, just to kind of keep this pretty straightforward, we're going to go to a degree of 3 for this. Okay, so we're going to go to a degree of 3 here and a degree of 3 here. Now, you're probably thinking, like for cosine, why are we doing a degree of 3 here? Because this is an even function. That only applies to Maclaurin series. I'm going to say that one more time. So what we've done so far only applies to a Maclaurin series. For sine and cosine, it doesn't matter. You'll see what we do. So for your convenience, we have the equation back up here for you guys, where now c is equal to pi over 4. So the first thing is we just got to start plugging stuff in, and this is going to come pretty straightforward to you, I hope. So f of pi over 4 is simply going to be equal, because that's the first part here, it's just going to be the sine of pi over 4, which is going to be equal to the square root of 2 over 2. That's our first term. That's our first term. So the square root of 2 over 2. So what I tend to do is I do like a little thing here. So I'm going to do f prime of x. And so f prime of x is going to be cosine of x. Again, we're just going to find a degree of 3. So we're going to do 3 derivatives here. So we're going to get cosine of x. And then we're going to get the cosine. So f prime of pi over 4 is going to be the cosine of pi over 4, which is also the square root of 2 over 2. And we're going to do this 2 more times. So the derivative of cosine is going to be negative sine of x. And really all we're doing to find the derivatives is we just want our values. That's really all we want. We really want the f of c, f prime of c, f double prime of c. That's really the idea that we want here. So f double prime of pi over 4 is equal to negative sine of pi over 4. And yeah, you don't have to show all this work, because I know you guys know that it's just going to be negative square root of 2 over 2. And you can figure out the rest of them as well. And then we're going to have the third derivative is going to be negative cosine of x. And that's going to be f triple prime of pi over 4, which is going to be negative cosine of pi over 4, which is going to give us negative square root of 2 over 2. So we have all the information that we need to actually solve this problem. And I apologize to all of you guys right now with the horribleness that is my handwriting. All right, so what is the power series? Oh, so power series. So power series is just another way of talking about a Taylor series. So if you guys see a power series, it's a Taylor series. There's many different ways that we're going to talk about power series when we get to throughout this course. But as of right now, I would ask you guys find the Taylor series. And you know this is a Taylor series because I'm telling you that c is equal to pi over 4. Okay, so now here's what we do. We're going to find this series. So Pn of x is going to be equal to. So we want our first term, which is the square root of 2 over 2. And then we want to do plus. We want our second term. We want the f prime of pi over 4, which is the square root of 2 over 2. And then this is what mistake students make. It's going to be x minus pi over 4. Still to the first degree all over 1 factorial. But do not forget to subtract your c. Do not forget to subtract your c. Then we want to go over here to the second term, which is going to be negative square root of 2 over 2. And I just do it like this. I do x minus pi over 4 quantity squared all over 2 factorial. We're not really necessarily looking to simplify this right this moment in time. We're just getting used to writing these things out. And then the third one, so now we're here, we're going to write that this is going to be, minus. And again, this is why you should just take a second and write these things out for this right here. So it's going to be minus square root of 2 over 2, and then it's going to be x minus c again, pi over 4, cubed over 3 factorial. And so one thing that you would see, this is not what they would expect you guys to see on your paper. If I asked you guys to take a test and what would this look like, you would see that they would factor out the square root of 2 over 2, because every single one of these, sine, cosine of pi over 4, no matter if it's positive or negative, will always be the square root of 2 over 2. So this is kind of what you would see. And you would see 1 plus x minus pi over 4. Sometimes they will simplify this, and then minus, and then you guys will see that this will just be 1 over 2 x minus 4 squared. So we're kind of getting rid of fractions instead of fractions with this. So these are all going to go away. Keeping the sign. Don't forget your sign here. So this is minus or negative. So again, minus, and so this is going to go up here. So it's just going to be 1 over 3 factorial. So this is going to be 1 over 6 x minus pi over 4 cubed. And this is what you would see. Again, you also have to just be comfortable realizing that this is equal to this. So this is the idea that you would see for this particular problem. Okay? So it looks completely different than the Maclaurin series for sine of x. Completely different, because again, you have to take it in. And the sine of x is going to look completely different for any other term for sine of, whatever c is. So if it's pi over 6, that's going to look completely different. You're going to have 1/2 and 3 square root of 3s over 2s and stuff like that. So again, we showed you guys an example where sine, pi over 4, they were all the same value. So we could pull out a common function, or common constant, I should say. All right, so let's look at cosine. And again, I encourage you guys in the first 2 videos, pause the video and see if you guys can do this with cosine with pi over 4. So let's go ahead and knock this one out as well. All right, so first thing we're going to do is we're going to do f of pi over 4. Sorry, pi over 2. F of pi over 2. So that's going to be the cosine of pi over 2, which is going to give us 0. Okay, so our first term is 0. So that's actually pretty crazy. Find our first derivative. So our first derivative is going to be negative sine of x. And that's going to be equal to, and so this one will be f prime of pi over 2. It's going to be equal to negative sine of pi over 2. Well, sine of pi over 2 is 1, so this is going to be negative 1. Find the second derivative. Derivative of negative sine is negative cosine. And you guys already know that this is going to end up being 0. I hope I can just skip that step, right? It's going to be 0, because I plug in pi over 2 to cosine, I'm going to end up getting 0. So anytime we have a 0, we can do that. And then the third degree is going to be the derivative of negative cosine, which is going to be sine of x. And so f triple prime of pi over 2 is going to be equal to sine of pi over 2, which is going to equal to 1. Okay? So I don't know if I erased this. I wanted to ask you, I think I wrote this at the beginning of the video. I wanted a degree of 3, so this is what it is. So we only have to go to 3. And so this one, we actually want to just find, well, the first term is just 0, so we can go ahead and just write this out. P n of x is going to be, well, since our first derivative is going to be negative 1, right? So this is f prime of pi over 2, and then we're going to do x minus pi over 2 to the first, because again, first derivative, all over 1 factorial. And then we're going to do plus 1, and then it's going to be x minus pi over 2. This was the third derivative, so cubed all over 3 factorial. So this is going to end up being negative x plus pi over 2. And most of the time, guys, they will pull the pi over 2 out. They'll do pi over 2 minus x when they simplify it a little bit more. And then 1 over 3 factorial, which is going to be 1/6 x minus pi over 2 cubed. Okay? And that's what you would expect to see. So I hope that makes sense. I think that that's a really good stopping point for Taylor series, so you guys can see that. Again, Taylor series takes more time. You have to find the derivatives. You have to plug in the values. But you guys see it's the same story. It's going to be whatever your function is, and it's going to be x minus that c to the power of which derivative you found all over the whatever factorial. So over here, again, I found my term. It's x minus pi over 4 I found the third derivative, so this is to the third, and then it's over 3 factorial. So the more you practice, the better you get. So I think that would be a really good chance to stop this video, and I'll see you guys in the next one.